Lesson 71. From the investigation that you have conducted before coming to this video, you will notice that when we find the definite integral of a function where its graph is below the x-axis, you always get a negative value. And any definite integrals that you take for the portion of the graph where the curve is above the x-axis, you get a positive value. When it comes to finding the area under a curve, we can deal with the problem of negative and positive area, so to speak, canceling each other out by taking the absolute value of f of x. Because when you do that, you're technically reflecting any portion of a graph that is below the x-axis to the positive side. Okay? As a result, we can use the formula that you see on the screen here. A is equal to the integral of absolute f of x from a to b dx. Example 1. Find the area bounded by the graph of f of x and the x-axis, where x is between 0 and pi over 2. On the card shown here, it shows you how you can actually ask your graphing calculator to graph only the restricted domain by following the steps here. Later on, I'm going to add a video clip to show how it can be done on the TI-84. Using the first graph here, I will actually have to divide my calculation into two sections and add the area separately. I know that on this graph, from 0 to pi over 4, whatever definite integral that I calculate, I will have to make it positive if I want to count the area. And then from pi over 4 to pi over 2, I can use this area as is. Okay? So I really need to take the negative of 0 to pi over 4 of 3 sine 4x plus pi dx plus pi over 4 to pi over 2 of 3 sine 4x plus pi dx, like that. Okay. Of course, if I can't be bothered, I can use symmetry and say that, well, technically, in this graph, this is really equal to 2 times the area between the curve and the x-axis from pi over 4 to pi over 2 of 3 sine 4x plus pi dx. Then I don't have to do that many repetitions from the calculations. Okay. When I do this, let's see what I get. I have negative 3 cosine 4x plus pi over 4, right? Using that reverse chain rule, pi over 2, pi over 4. I can then do my evaluations. I have cosine 4 times pi over 2. 4 pi over 2 is 2 pi plus pi, that's 3 pi. Minus negative, so plus 3 over 4. Cosine 4 times pi over 4 is pi plus pi, 2 pi. Okay, cosine 3 pi, that's negative 1. This is 3 over 4. Cosine 2 pi is 1. So plus 3 over 4 again. That means I have 6 over 4 times 2. But 6 over 4 is 3 over 2. So the answer is 3 square units. Like that. Okay. Of course, method 2 says that, well, you can actually just graph the absolute value of f of x and do your evaluation, which will give you the same answer. Question 2. Find the area bounded by the graph of f of x equals to x cubed, x equals to negative 1, x equals to 1, and the x-axis. So the starting point is here, -1, +1, and anywhere between the red curve and the x-axis. Once again, symmetry comes in handy because I know the two areas are actually equal to each other. As a result, area can be twice of the area from 0 to 1 of the graph x cubed dx. You don't really need to put the absolute value sign here because on the positive side here, we have the graph is positive, the area is positive anyway. This gives me 2 times x to the power of 4 over 4 from 0 to 1. And then plugging in 1, I have 2 times 1 over 4, which is 1 over 2 square units. Question 3. Find the area bounded by the graph of y equals the square root of x and the y-axis between 1 to 3 on the y-axis. So we have to be very careful when we read our questions. Notice how this time we're actually finding the area between the graph and the y-axis at 2 different levels of y. We just have to make one slight adjustment here. Because we'll be taking the integral with respect to the y-axis, we have to make sure we express the function of x in terms of y. Okay? So starting with y equals the square root of x, I can now say y squared is equal to x. This is the function that I'm interested in. And you notice how in this definition, it is f of y dy. Okay, so here we go. The area then is going from the y-axis from 1 to 3. We're taking y squared dy. I have y cubed over 3 from 1 to 3. I have 3 cubed, 27 over 3, 9, minus 1 cubed over 3, which is 26 over 3 square units. And this is how you can find area between a function and either the x or y axis between a given interval.